Let's go over solving a couple of trigonometric equations, starting with this one here. When is 2 times sine theta plus 1 equal to 0? And we want to solve this for all values of theta. Well, the trick is we can just treat this sine of x as its own variable and solve for it. So like step 1 would be, let's subtract 1 from both sides of the equation. We get that 2 sine of theta is equal to negative 1. You could then divide both sides by 2. And you've isolated not the variable itself, but you have sine of theta is equal to negative 1/2. Well, the question is, what angles for theta make this thing a true statement? So over here, I'm going to refer to the unit circle. Now, what's going to be helpful here for solving this equation is knowing a couple of angles. And those angles are 30 degrees, 45 degrees, and 60 degrees, or their equivalent in radians, which is pi over 6, pi over 4, and pi over 3. I wrote these because, well, I know, and if I'm working in radians, that sine of pi over 6 is equal to, it's not negative 1/2, but it is positive 1/2. But I can use this to figure out where sine is negative 1/2. So for starters, on my unit circle, sine represents the y value, and I'm going to first draw in where pi over 6 is roughly. So if I want to find pi over 6, I don't know, maybe it's something like this angle here. Like this looks like a 30-degree angle, which is pi over 6. And this y value is equal to 1/2. So it's easy to see another y value that is equal to 1/2, and that's over here. I'm going to draw it on here. So here's another angle. Clearly the y value is 1/2, but it's at a different angle. And this angle is, okay, well, if I rotate half a circle, that's pi radians, same thing as 6 pi over 6. So it must be that this angle is 5 pi over 6. One less than 6 pi over 6. So what this means is, well, sine of pi over 6 is 1/2, but so is sine of 5 pi over 6. For this angle, you also get 1/2. Now, where are the y values not positive 1/2, but negative 1/2? So negative 1/2 is, it's like right about here. So here is negative 1/2. This is a corresponding y value, and this is a corresponding y value. There are two angles where sine is equal to negative 1/2 as you rotate between 0 and 2 pi radians. So, what angle is this? Well, this is going to be one more than 6 pi over 6, which is 7 pi over 6. That's one of our answers. So here is one answer to our equation. In radians, theta is equal to 7 pi over 6. Fantastic. Now again, I got that by saying, well, by symmetry, negative 1/2 would go down here. So instead of rotating back to 5 pi over 6, I went forward to 7 pi over 6. So then where's this other angle? Where is the one that goes from here to here? How can I figure out what this is in radians? So the way I'll figure this one out is by noting that if you go a full rotation, you've gone 2 pi radians. And that's the same thing as 12 pi over 6. To go from here to here, you don't go up pi over 6, but you go back or down pi over 6. So you're reducing this by a pi over 6, and that gives us 11 pi over 6. So this is a second answer. Here are two answers to this equation, and where it came from was, I know the y value on the unit circle can take on negative 1/2 in two places, and we define sine to be the y value. Therefore, there must be a couple of answers. Okay, but technically, if we're looking for all angles, well, there's more than just, these two. And the reason for this is, well, you could rotate another 2 pi radians, you'd get a different angle measurement, but you're back at the same spot. And you can do this infinitely many times. And you can even go backwards. So I guess what I'm saying is, if we focus on this angle of 7 pi over 6, well, you could also add 2 pi to it and get the same exact location just with a different angle measurement. And you could also subtract 2 pi from it and end up at the same spot too. And you can do this for any multiples of 2 pi, like 4 pi, 6 pi, 8 pi, and so on. The general way to express your answer would be like this. If you have one angle, you can either add or subtract any multiple of 2 pi and end up at the same location, but just with a different angle measurement. So when we say all angles, this would be the full answer. There's infinitely many solutions. So you have to tack on this thing. It looks a little strange, but this would be a solution to this equation. Same thing goes for this 11 pi over 6. If you either add or subtract a multiple of 2 pi, you'll be at this location here. That's a y value of negative 1/2. And that means it's a solution to our equation. So that's it for this problem. For example 2, what if we work with the same equation, but this time we put a restriction on where theta must be located? So what this means here is we're not saying use infinitely many angles, but we're stuck between negative pi and 3 pi. Well, what would the solutions to this equation be then? Well, there won't be infinitely many, there will only be a few, but how do you figure out what they are? So here's what I'm going to do first. I'm going to mark on this unit circle what it means to start at negative pi and end at 3 pi. So to begin with, here is 0 radians. And if we go back here, if we do half a rotation clockwise, this would be a negative angle, and we'd call this negative pi. So like negative pi is our starting point, and then we're rotating in this direction until we get to 3 pi. So going from here to here would take us to 0 radians. Another full rotation would take us to 2 pi, and then you go another half rotation until you get to 3 pi. So I'm going to try to draw that in here. Hope it won't be too messy, but this is what I'm thinking. I'm thinking, okay, we're starting here. We rotate until we get to here. And once we get to here, okay, I'm back at 0 radians. And then we rotate again. Okay, here we're at pi radians, but we're keeping on going until we get to here. Okay, now we're at 2 pi. And then we go a little bit more. Adding pi to 2 pi would take me to 3 pi. So this is like what I'm visualizing. It's kind of a mess if you draw it, but I want all the angles going from negative pi to 3 pi, and I want to include those in my answer, and only those. So we already solved this equation, right? We solved for sine of theta, and we got what was equal to negative 1/2. And then we saw the angle measurements were, well, one was 7 pi over 6, plus we would add multiples of 2 pi, or subtract them. And another one was 11 pi over 6, and we either added or subtracted multiples of 2 pi. Let's start with this one here. This 7 pi over 6 meant you started at 0, and you rotated until you got to here. If you want to get another one, okay, what you could do is rotate 2 pi to that, which means you go around, you're now past 2 pi, and if you do that again, okay, you're here. You're back at the same location. This would be 7 pi over 6 plus 2 pi. Now the question is, did we go too far? Did we actually rotate past 3 pi? And I think the answer is yes. If you go from here to here, that's 7 pi over 6. Once you get to here, you're at 2 pi. And then here you're 3 pi. So if you do this, you've actually gone past the interval that we're allowed to work in. I think we can actually see it from this computation too. So like if you were to add these two things together, let's see, well that's 7 pi over 6 plus 12 pi over 6. That is the same thing as 19 pi over 6. And 3 pi, if you think about it in terms of something over 6, well 3 pi is 18 pi over 6. So let's put that as a reference. So I know that 3 pi is really 18 pi over 6. Okay, this is greater than that. I don't want to include this one. So it's like, okay, I don't want that. I don't want to add 2 pi to it. But what about subtracting 2 pi? So I'm going to make a little bit more room for this. So I'll get rid of this down here. Okay, but what if I, like I was saying, don't add 2 pi? What if I take 7 pi over 6 and I subtract 2 pi? Which would be saying you take 7 pi over 6 and you subtract 12 pi over 6. Okay, if we take the difference, we get negative 5 pi over 6. Now, as a reference, if you go backwards to get to this first starting point, that's negative pi. Negative pi is the same thing as negative 6 pi over 6. And so negative 5 pi over 6 means you didn't go quite to negative 6 pi over 6. This means we actually have another solution. I'm going to add it to my list. I'm going to add on, well, I also want negative 5 pi over 6. This will be the first one. So we start at negative 5 pi over 6. I do one full rotation. I get to 7 pi over 6. And if I add one more onto that, then I've gone too far. These are the only solutions that are coming from this original angle that fall in this interval. All right, but we still need to check that other angle, which I'll put back up here. So our other angle that we were working with, so I'll just kind of close that off. It was 11 pi over 6. You could potentially add or subtract multiples of 2 pi to this. Those angles might fall within this interval, and I want to make sure I include those. So to start with, 11 pi over 6, it does fall within the interval. That means you start at 0, and you're rotating, but you're here. Like you don't ever go past 2 pi, so you're at this spot here. Clearly, if you add 2 pi to this, so if you start adding, you're already past 2 pi, you're now past 3 pi, so whatever angle you get by adding 2 pi, it's definitely going to be bigger than 3 pi. If you want to see that, so look off to the side. If you take 11 pi over 6 and you add 2 pi, you're really adding 12 pi over 6, and 11 plus 12 is 23 pi over 6. That's definitely bigger than 3 pi or 18 pi over 6. So again, I don't want this one. This is no good. I will not include this. But I do think if we subtract 2 pi, we will get a value that works. So let's try that. Okay, so I'll take 11 pi over 6. I will subtract 2 pi, or I mean, really, I'm subtracting 12 pi over 6. And 11 minus 12 is negative 1 pi over 6. This one's good. So that's, we went to 11 pi over 6. We went backwards 2 pi. So that's like saying you're starting at 0 and going back to negative pi over 6. You clearly didn't go back to negative pi because negative pi over 6 is not as far as negative 6 pi over 6. That's another solution. So I'll include that in my list. I want to include negative pi over 6 as well. So what does all this mean? It means there's actually 4 solutions to the original equation. When you start adding restrictions on the angle measurements, it actually becomes complicated only because you have to think about the angles that work. Like we had a couple initially. We got the rest by adding or subtracting multiples of 2 pi. But here you just have to be careful, well, how far can I go? How many 2 pi's can I add? How many 2 pi's can I subtract? And these will be the 4 solutions to this equation.